Best teachers पढ़ाए तो simple लगे everything. Leaderboards and quizzes से
Amazing.
learning हो जाए happening. समझ आएगा तो मजा आएगा. Vedantu, learn live online. To attend a free live class, download the app now.
Hello everyone, good afternoon. Hi Takla Belchat, or I don't know how, I can't even pronounce the name, but I think it's good. Rajni, Nancy, Sanju, Ramicha. Then who all are there? Sanju, I can see the same names repeating again and again. Srishta Reddy, okay, good. So how are you all? How nicely are you enjoying this fine afternoon? Tell me that. Sums on optical instruments. Hi Prajwal, Piyush, Santosh, Naveen. Tell me, how are you all? Okay, Takla, I took your name. Okay, all good, happy. It's good thing that you are a Mallu. I'm also one. I'm from Calicut. Your first live session. Okay, so I'll try my level best to make this as such an awesome session for you. Okay, so how are your studies? Guys, other than hi, tell me how you doing. Tell me how's your studies going on. Nothing? Quiz answer is 4/3. We'll look into that. Which quiz you are talking about? I forgot. Awesome. All good. Okay, so what can I tell you is I know that everyone will be doing super great. So I hope you know that we are doing the series and we are having some timetable over here where we'll be taking the classes one by one till capacitance till 28th Jan. It is over. So what I'm referring to you is whatever is taken by us, you can take the same schedule for your studies because we'll be completing the physics, all the chapters of +2 before 20th of Feb. So we can follow the exact schedule what we are following. So when you come to my class, you can study the portions whichever is going to be taught on that particular session, and you can go on the same day and you can study after my class also. So by the end of the series you would have gone through entire physics chapters and you will be so awesome, right? Hi Balram, yo. Okay, yo. Modern physics we'll do all the chapters. Okay, look, this is not the thing. So you can take the next dates are also there where I'll be taking the classes exactly at 1 o'clock on all these dates which is given over here. Okay, so I expect every one of you at the right time to be in my session. Okay, not even late by a single minute. My physics model, okay, don't worry, we can adjust everything. Okay, and I'll try to help you to give most number of questions which will help you for the model question also, right? Okay, so I know that for so many out there my face will be new for them. Myself, Ameer Basit, master teacher of JEE physics at Vedantu. You can call me Ameer for anything and everything, but only for physics, right? Okay, so I hope you might be knowing why we are here. We are here as a part of CBSE sprint where we'll be preparing ourselves for the upcoming CBSE board exam, right? And we'll be doing as many number of questions between the previous year questions and in a chapter wise manner, and we'll be making a quick revision also. So I hope you might have understood which are the chapters which we have already covered, right? So now on today and day after we'll be covering that beautiful topic which is important at the same time and which is going to help you grab a lot much of mark, which is current electricity. As it is that important, we are taking 2 sessions today, and on 31st of Jan we'll be doing the current electricity. Guys, I hope everyone will be there. Okay, hi Pratiksha, all good? So Master Pada Jo Jaldi. Okay, thank you so much. Okay, so someone is there. So before that, I have to give the names. Okay, do you know what are these names for? These are the person who answered it for the first time and for the question whichever is given in the YouTube session. Okay, so everyone who give the right answers will be displayed, and whose name is coming most frequently for a month, they will be awarded with so much of gifts from Vedantu. Okay, so keep doing it, keep following us, and grab lot much of gifts in your hands. Yes, congratulations to the winners. Look, Pratiksha is there to congratulate everyone. मेरा पहला class है आज पढ़ा बता. Okay, I'll teach you. So before that, I know that so many were there in my last class also. So who were there in my last class? Please, if you like it, please don't forget to like the videos, and if you think that this is beautiful and helpful, do share with your friends, and don't forget to subscribe and help us to do lot much of videos. Okay, all good. So subscribe guys, don't wait. So shall we go and do the first question? Thank you so much Anshu. Thank you so much. Okay, so this is the first question which is there. We are going to do, this is a small question, so we'll slowly increase the level of the question. So first question, what does it say? Nichrome and copper wires of same length and same radius are connected in series. So it is a series connection. If it is a series connection, what should be there in your mind? The current is the same, right? Current I is passed through them, and which will be the same. Which wire gets heated up more? Okay, so which wire heated up more? So we'll draw a small picture of that, because pictographical representation are always helpful for the exam point of view. So you have one wire, let me tell that it is nichrome, and let me do it with a blue color. This is what wire? Copper. So you have nichrome over here and you have copper over here. Okay, for them the lengths are the same, okay, and radius are also the same. So I am writing it with L, R and R, right? Okay, so the question is, once they are connected in series and pass through a current of I, now the question is, what will be the connection between the current? As I have already told you, let me see who all remember it, whether the current in both of them will be the same or different. Can't see blue color? No worries, nothing is there. Okay, then let me choose green color. Now is it visible? Okay, I hope that is visible, right? Now you're done. Now can you see, I hope? Now nichrome wire has one thing that you have to keep in mind is nichrome wire has more resistivity than the copper, right? Which we use in iron boxes and all those stuffs, right? Before that, let me ask you, what about the current? What is the relationship between the current passing through both the wires? Tell me that. The current passing through both the wires are the same. Why it has to be the same? Because it is written here that both are connected in series. So this thought should come. Okay, very good everyone. Okay, so that thought should be there in your mind. When it is connected in series, the thought should be there in your mind is current is same. So the formula for heat energy is equal to I square R into T, right? So I is the same in both, T is same, so heat produced is directly proportional to the resistance, where resistance is equal to rho L divided by A. In both the cases, length and area are the same. If it was different, we should have calculated the resistance, but the only difference is with resistivity. So heat is directly proportional to resistivity. Whichever is having more resistivity, that will be producing more heat. And which one is having more resistivity? Which one is having more resistivity? Tell me. The nichrome wire. Very good Sakriti. Okay, Shivanshu. So everyone understood this particular question? Simple question, right? Vivek. So okay, hi Vivi. Good. So I hope everyone have understood, guys. All good. So let me move to the next question. Yes, Risha, Daksh, so many other who's going to Anju. So next question is waiting for us. Let's not waste our time. So the next question. I'm all good. Thank you so much for asking. So the question is, two wires X and Y of same diameter but different materials are joined in series across a battery. Again in series, so same current. Okay, two wires X and Y. If the number density of electrons in X is twice that in Y, number density means number of electrons per unit volume, which is written with a small letter n. Find the ratio of drift velocity of electrons in the two wires. Okay, as it is connected in a series fashion, the current is the same, so you have to make an equation for the drift velocity. As something is being mentioned about the current, you can choose the equation for drift velocity which contains current, right? Okay, so what is it? So that is equal to I is equal to N. What is N? Number density, right? Area drift velocity into electrons. Yes or no? So drift velocity as a formula of I divided by NAE. Now if you look into the formula of drift velocity, current in both the wires are same as they are connected in series. Next, area is the same because it is mentioned that it is of same diameter. Yes. Then E is the electronic charge. It is 1.6 into 10 power minus 19. Okay, so many are giving me the answers. Good. So drift velocity is proportional to what? N, right? So drift velocity of X divided by drift velocity of Y is equal to n of y divided by n of x, because it is inversely proportional. So what is it given? The number density of electrons in x is twice. So x can be written as 2 times ny. This is ny, so it cancels. So the answer is how much? Very simple, right? It is 1/2. Understood, everyone? Pratiksha, Pranav, Daksh, all good? Very good, very good. Shivansh, Rahul, great, great, great. So many who got it. Chantana, Pratiksha, Jay, Satyam, Subrata. Okay, I'm totally enjoying the vibe over here because everyone is so active, though it is a fine afternoon, right? So shall we go to the next question? Yes or no? Yes, very good. So next question is right in front of you. So what does it say? A cell of EMF E, internal resistance R, is connected to two external resistance R1 and R2, right? And a perfect ammeter. Perfect ammeter means it is an ideal ammeter, which means no resistance is provided by the ammeter to the circuit. That's what you mean by a perfect ammeter. Then the current in the circuit is measured in 4 different cases. The 4 different cases are given. Which are it? One is without any external resistance, which means in the circuit only internal resistance of the cell is there. With resistance R1, with R1 and R2 in series, R1 and R2 in parallel. Okay, the current measured in 4 series between 4 different cases are also given, but they are asking to match the first 4 cases with the current passing through them. So as you know that the same EMF is being provided, the current in the circuit is totally dependent upon what? The current in the circuit will be totally dependent upon what? Look, current is equal to totally dependent upon the potential given divided by the resistance, right? Or you can say that the current is, what can you say? What can you say? The current I is directly proportional to 1 divided by R, or the resistance, which means when the resistance is more, the current will be less, or when the resistance is less, the current will be more. Yes or no? Yes or no? Yes. Give me 1 minute. Okay, so what are we going to do is, as it is inversely proportional to the resistance, whenever the current is more, it is resistance will be less. So we have to check the minimum value of resistance where it will be giving maximum value of current, where in all the 4 cases the resistance is minimum. In all the 4 cases, where can you find the minimum value of resistance? Where can you find? Yes, I'll tell you a name once you give me the answer. Where can you find the minimum? Where can you find the minimum value of resistance? Is it in the first case, right? Because there is no other external resistance is given. So there you can expect a maximum value of current, which is how much? Which is given as how much? 4.2 ampere. So the 4.2 ampere corresponds to the first case. Yes or no? So I'm telling first case is having a current of 4.2 ampere. Now we have second, third and the 4th case. Fine. Now among the remaining 3, where can you find the minimum? Among the 3, which means 2, 3 and 4, where can you find the minimum value of resistance? Where can you find the minimum value? Pratiksha, Vivek, Arshdeep, who is going to tell me? Where can you find minimum value? Very good. Then in the parallel, right? I hope nobody is having any doubt on that, right? Because think that if it is only, we'll take resistance R1 as R1 is equal to 1, R2 is equal to 2. So if they are connected in parallel, let's see what will be the value if they are connected in parallel. Equivalent value of resistance is equal to R1 into R2 divided by R1 plus R2, which is 2/3, which is lesser than R1 and R2 also, right? So the minimum value for the resistance in the next case is the connection of these two in parallel. So the next higher value of current will be for the parallel connection, which is for the 4th, and which is the next higher value of current? Which is the next higher value of current? Tell me, Pratiksha, Shreya, Khan, who will tell me which is the next higher value of current? It is 1.4 ampere corresponds to the 4th option. So it is 1.4 ampere. Yes or no? Yes. Then we can go for the next one. in the R1 and R2 in series? Which one has minimum? Which one has minimum? Monu, Shaurya, Ankya, Siddiqui, which one has minimum resistance? It has R1 only, right? So then R1 has the maximum value of the current among two. Then which is the maximum value of current which is available now? Which is 1.05 for the second case. And the remaining is how much? 0.42 ampere. So this is how you arrange. Yes, understood everyone? I hope nobody is there, okay, without understanding this particular question and how to do it. Say yes or no? Guys, yes, good, Makhan clear? Suraj, Prajwal, Nancy? Yes, all good. Thank you so much. Makhan clear, thank you. Okay, sir, please take my name. Okay, yup. How can I take your name? It isn't even your name, right? Okay, next question. Let's not waste our time. We have the next question. Okay, good. Look, read the question. In the meter bridge experiment, meter bridge works on which principle? Who will tell me? Before starting with the question, let me ask, meter bridge works on which principle? We'll do the Kirchhoff law. Next question is based on Kirchhoff law. Okay, Prajwal? Don't worry on that. Now tell me. Meter bridge works on, very good, it works on Wheatstone bridge, Sukriti, Pranav, Udit, okay? So it works on Wheatstone bridge. So meter bridge works on Wheatstone bridge principle, which says if the current passing through the galvanometer is 0, the ratio of the resistance is equal to the length of the wires of the balancing point. So what can you write in this case if L is the balancing point? If L is the balancing point, what can you write? The ratio of resistances, which is R divided by X, will be equal to how much? R divided by X will be equal to L divided by 100 minus L. Why it is 100 minus L? Because in the meter bridge the total length of the wire is 100 meter. So if this is L, the remaining part will be 100 minus L. So I hope nobody is having it out. Very good, Pratiksha. Yes, they were the 10. Good. Okay, very good. So now what is happening? Now they are asking for the new position of the balancing point when some changes are made. What are the changes they are making? First, the values of R and X were doubled. Now, if the values of R and X are doubled, both are doubled, so I am making 2R and 2 times of X. Will the balancing point change? Will the balancing point change? No, it won't change at all, right? Okay, so there is no change. Now what is the thing that they are making? R and X were doubled and then interchanged. Now what they did, instead of R and X over here, they are keeping X over here with twice the value with 2R over here. So this became 2R, X and 2R. So now the ratio of the lengths will be equal to how much? 2X divided by 2R. If it is 2X divided by 2R, what will happen? What will happen? This will also become ulta, right? So this will be 100 minus L divided by L. So what is the new point? What is the new point now? What is the new point? Yes, it will interchange. What is the new point? New position will be equal to 100 minus L. Very simple, right? So I am asking you, if you know the concept, you can do any kind of question. Okay, I believe in all of you guys. What you have to do is believe in yourself. You can do anything and everything. Very good. So I hope everyone have understood, right? Next question. If the galvanometer and the battery are interchanged at the balance position, how will the balance point get affected? Who knows? Who knows this? Who knows the answer of this particular question? No change will happen, right? First of all, we'll discuss about the galvanometer. If galvanometer is changed, no effect itself will be there, because first of all, there is no current passing through the galvanometer, and galvanometer doesn't have any influence on the balancing point, right? Now let's see what happens if this voltage is increased. If this voltage is increased, the potential dropped across the wire will increase, right? And if the potential dropped across the wire increases, potential gradient will also change or increases. If the potential gradient, what do you mean by potential gradient? What do you mean by potential gradient? Ankiya, Rajani, Sankriti, who will tell me what do you mean by the potential gradient? It is the potential dropped per unit length. If you take 1 meter, how much is the potential drop across that wire is called as the potential gradient. So the potential gradient will change, of course, but though the potential gradient changes, it doesn't have any influence on the ratio, right? It doesn't have, does it have any influence on the ratio? Very good, Prajwal. Does it have any influence on the ratio? Very good. Everyone knows. Siddiqui, Shreya, Ankia, Rajni, Richa, all good. Whoever is giving the answers, all awesome. So there is no I'm sorry guys. Okay, so there is no influence for this potential gradient on this ratio, so it is not going to change, right? Say yes or no, Pratiksha? Yes, I'll have it. Thank you so much for the care, Pratiksha. Okay, so I'll have it. Thank you, Pranav. Okay, now I'm good. So let's do the class. So I hope everyone have understood. There is no change is going to happen. So thank you so much for the care and listening to my class. Okay, keep doing this. Okay, and we can work together and make your coming exam so awesome. So next question. So someone was asking about the Kirchhoff law. So both the laws has to be discussed here if you want to complete this particular question, right? Okay, so the question goes like this. What is the question? In the given circuit, assuming the point A to be at zero potential, so this point I am taking it as zero potential, what is it? Use Kirchhoff rule to determine the potential at the point B. This potential we have to use. Thank you so much, Manas. Okay, so how will you find out the potential at the point B? So which we have to use? Kirchhoff tricks. If you want me to discuss, I think I have to take another video for that, because there are so many tricks based on it. So here this is a very simple circuit, so we don't have to do any of the tricks. What you have to do is we have to use the basic Kirchhoff rules, which is the Kirchhoff first law and also the Kirchhoff second law. So what is said in the Kirchhoff first law? What is said in the Kirchhoff first law? Not Wheatstone-Bridge, first law. Yes, what does it said in the Kirchhoff first law? Says whatever is the amount of current coming to the junction, the same amount of current will be going out of. Thank you so much, Rajini. Okay, so I'll explain you that. So listen over here. So think that this is a interconnection where current is coming, which means this is I1, I2 and I3 is coming, and if these are the two current which are going out, I4 and I5, Kirchhoff first rule says that what? I1 plus I2 plus I3 is equal to I4 plus I5. Yes or no? Just like if water is coming through 3 pumps, it has to go out of the other 2 pumps, right? Because there is no other point for the water to get accumulated. If the water get accumulated, it will start bursting, the tube will start bursting. Just like that, whatever is the amount of charge coming, it has to come out. It can't get accumulated at any point. So this is Kirchhoff first law, right? Very good. Now second law, what I'll say. So think that if this is a second law, I'll draw a small loop and I'll make you understand about this Kirchhoff law. So think that you are having a resistance. This is R1 and this is one cell E1. This is R2. This is another cell. Let it be bigger one like this, and one more cell like this and like this. So this be E2 and E3. Okay, just a small circuit I have made so that I can explain you about the Kirchhoff loop rule. Sorry, Kirchhoff second law. So what is said in the Kirchhoff law? You have to travel across the loop from one point and you can end up at the same point. Okay, so during that process, if I am traveling from the first point and ending at the same point itself, what will be the potential difference then? What will be the potential difference between the same point? What is the potential difference? VA minus VA is equal to 0, right? VA minus VA is equal to, tell me fast, will be same, which means if you subtract whatever is the potential difference will be equal to 0. So that is a basic rule about the Kirchhoff loop rule. So starting from the potential over here, and think that the current I is passing in this direction. So if I am traveling in the same direction of the current, what will happen is across the resistance, if you're traveling in the same direction of the current is flowing, the voltage will be dropped or it has to be subtracted. So the voltage dropped across I1R1 is I1R1 and it has to be written with a negative sign. I hope you have understood, because voltage is getting dropped over there because we are traveling in the same direction of the current. Yes? Chandana, Arsi, Mayank, Manas, Daksh, right? Okay. Now, if you are meeting up with a cell and during the traveling, if you are ending up at the positive terminal of, because you are traveling in the clockwise direction, you are ending up the positive terminal, the EMF has to be added up. So it is plus E1. Right, now you're traveling in the same direction of the current I1 itself, right? So the potential is dropped. How much is dropped? Minus I1 R2. Now you're traveling with this cell. You are ending up at the negative of the cell. So if you're ending up at the negative of the cell, the potential has to be done with a positive sign or a negative sign according to Kirchhoff. Tell me, tomorrow there is no class, day after tomorrow is there, Friday. Tell me. In this case, it has to be with a negative sign. Very good, Chantana, Pratiksha. It has to be with a negative sign because this is reducing the potential in the circuit. That's why we are having a negative sign, which is E2. What about E3? Plus or minus? What about E3? We are ending up at the positive of the terminal, so it has to be added up, right? So that is equal to plus E3 will be equal to 0. What will be the total potential difference between the same point? Will be equal to how much? Will be equal to how much? Positive. Very good, Shama. Shiv Kumar, very good. Now it will be equal to how much? What's the potential difference? Potential difference becomes, very good, Aditya, it is 0, not 1. Potential difference between the same point is equal to 0. This is simple as that. This is what you have to do all. Okay. Monu, Pratiksha, Prajwal, Rajini, Jayan, Chandana, okay, all good. Thank you so much for the participation. It will be 0. So this is about Kirchhoff first law and Kirchhoff second law. Yes or no? I hope everyone have understood. So if you guys have understood, shall we do this particular question? Right? Okay. So the question is, what is the potential at the point B starting from A? So if you want to, you have to travel in this fashion, right? You are traveling in this fashion. Someone can ask, why can't I travel like this? Why can't I travel like this? Someone can ask me, why can't I travel like that? Why can't I travel like this? Because the resistance at this particular point is not mentioned, right? So I cannot travel like that in order to find out the potential at the point B. So which way I have to travel? I have to travel like this, right? So this is not good. So I have to travel like this. If I want to travel like this, I should be knowing the current over here. So if you want to know the current over here, as it is not given, you have to use Kirchhoff loop rule. How will you find it out? How will you? Because 4 is coming to the junction, 1 is going out. So how much will be the current through this? How much will be the current through this? Because it has to be 3. Whatever is coming to the junction, it has to flow out of the junction. If 1 is flowing, the remaining is 3. So here you have 4, right? Sorry, you have 3 over here. Now the current is there, Aditya, Shivanshu, very good. So current is there, then you have all the potential. So starting from the point A. So starting from the point A, VA. I'm writing it a potential at A as VA. This will add up the value of EMF or will be subtracted. This 3 volt has to be added up or subtracted. Rajini, Chandana, tell me the answer now. Added up or subtracted? It has to be added up because we are ending up in the positive terminal of the cell, right? So VA plus 3, right? Okay. We are traveling and we are traveling in the direction or on the opposite direction of the current. We are traveling in the opposite direction of the current, right? We are traveling in the opposite direction of the current. So here also we have to add it up. How much we have to add up? Current into resistance. Current is 3, resistance is 2. So that is 3 into 2 as we are traveling in the opposite direction with a plus. Now we are going. Okay, we are ending up in the negative terminal of the cell. In the negative terminal of the cell, if you reach how much? It is -6. If you do all these things with the potential at A, what will you get? The potential at B. So the potential at A is changed by this much of things. If you change the potential at A by this much of things, you will get the potential at the point B. Yes? All good? Okay. Now just use it. 3 2s are 6 minus 6, right? So VA, what is the potential at A given? A to be 0. So 0 plus 3 is equal to VB. So what is the potential at the point B? What is the potential at the point B? Tell me fast. It is plus 3, right? So I hope everyone might have understood. All good, happy. So it is 3 volt just like we got, right? Okay. So another question is there. Okay, all good. I'm so happy with your comments and your activeness and energy in the class. I'm so happy. I'm so overwhelmed. Okay, Suraj, Shama, Chantana, Prajwal, Dhruvan, Sharshdeep. Okay, okay, Dhruvan, I took your name. Shama is okay. All good. Happy with my teaching. I hope, Pratiksha, right? All. I hope everyone is happy with my teaching. I hope everyone is understanding. Yes, yo. Okay, thank you so much. And let us move. Okay, so someone has already started to answer for the question, right? Thank you so much. Now listen, define the term conductivity. Just like anyone can say, it is the inverse of resistivity, where resistivity is defined as R is equal to rho L by A. Rho is the resistivity, right? So inverse of resistivity is conductivity, or conductivity can be defined as the amount of current that can be passed through that particular material can be defined as conductivity, right? If conductivity is more, the current that can be passed through the material will also be more, right? It will be a good conductor if the conductivity is more, right? Okay, so that part is done. Now the question is, using the concept of free electrons in a conductor, derive the expression for the conductivity of a wire in terms of number, density, relaxation time, and all those things. Okay, so in terms of that, you have to derive a formula for the which one? Conductivity. Before that, you should be knowing there is one more equation for conductivity. So the conductivity is given by the equation of conductivity is given as sigma is equal to J divided by E. Do you know what is J and E? J is the current density, which is equal to current divided by area, and E is the electric field applied. The ratio of both of them will also give you what? Will also give you the conductivity. Yes or no? All good? Shivansh, Shama, okay, no name, no name. Right, okay, very good. Pratiksha, okay. So now if you want to make a relationship for this conductivity, it is equivalent to find a relationship for this current density, and you can substitute in this equation and find out equation for conductivity, which I am going to do it. So current density J, as I have told you, it is current divided by area, right? And as you want in the equation what? The number density, you can write the current in terms of the number density. What is the formula? Current is equal to NA drift velocity into E divided by area. I hope everyone knows this. Yes or no? So drift velocity, electronic charge, area of the wire, and number density divided by area. You will have NVD into E. Okay, good. Next is the formula for the drift velocity. What is the formula for the drift velocity? Everyone knows, I hope. So J is equal to N into E. This N and this E. What is the formula for drift velocity, which I am going to substitute now? Okay, Aman, I took your name. Now tell me. It is equal to E by M into 2. So what all are this? Electronic charge, electric field, mass of the electrons, and tau is a relaxation time. Thank you so much, Ameer Sir, best sir. So what is that relaxation time? Pratiksha gave me the answer. Dark colors, okay. I'll choose black then. Okay, so what is the formula? What do you mean by the relaxation time? Relaxation time means the time required for the electrons in between a successive collision is called as a relaxation time. Okay, very good. So many are giving me the answers. I'm so happy. Okay, so let us rearrange this. That is N E square by M tau into E, right? Okay, so what you can do, J by E is equal to N E square tau divided by M. What was J by E? What was J by E? It was equal to sigma. So you got the relationship for what? You got the relationship for what? What do you got now? You got the relationship for the conductivity in terms of number density. Yes? Yes, very good. Alka is giving me the answer. Okay. Sneha is giving me the so many suggestions. Okay, so I'm using only black color now so that you can easily view that. All good, all happy with this question? I hope so. Let's move to the next question then. Okay, Next question, simple question it is. Those who want to do by themselves and give me the answer can give me. Okay, so the question goes like this. Okay, someone was telling me Adiboli class. Okay, Prajwal. Okay, you are a Malu, right? Okay, thank you so much. Sir's favorite Pratiksha. No, she'll be there in all my classes. That's why I know her. So that's why. Okay, nothing like that, Pranav. You are also my favorite. Chandana is my favorite. Risha, Shama, everyone is my favorite. Okay, good. Question. So the potential difference applied across a given resistor is altered so that the heat produced per second increases by a factor. What is heat produced by a second? Heat produced by a second means power. Okay, so they are talking about the power. So a resistor is altered so that heat produced per second over the same resistor is changed by 9. So by what factor does the potential difference changes? Okay, keeping the same resistor, it doesn't have any connection with this. Okay, so keeping the same resistor, the heat dropped, or the heat produced across that resistor is made 9 times. Okay, so they are asking what is the change in the potential. So as you know, the heat energy produced, which is power, is given by the equation of what? Power is equal to V square divided by R. As it is across the same resistor, we are going to write what? Power is directly proportional to V square, right? The power is made 9 times. So if I make it as an equation, what will I do? P2 divided by P1 will be equal to V2 by V1 the whole square. I hope I have written it in a simple thing. Okay. Don't start a fight there between everyone over there. Okay, everyone is my favorite. Okay, so don't start a fight there. Everyone is my favorite. Prajwal, Tushar, Shama, everyone is my favorite. So P is directly proportional to V square as it is across the same resistor. Yes or no? Okay. So as you can write, P2 by P1 will obviously be equal to V2 by V1 the whole square. What has happened to the power? It became 9 times, right? So P2 is equal to 9 times of P1 by P1 is equal to V2 by V1 the whole square. Okay, so P1 will be cancelled. So you have 9. So V2 by V1 is equal to V2 by V1 the square is equal to 9. So V2 by V1 will be equal to how much? V2 by V1 is equal to 3. So V2 is equal to 3 times of V1. Yes, all good, understood, happy with the question. Rajni, don't start a fight over here, please. It's not good, right? So we are here to learn something. Nothing. Okay, no grudges, all happy faces. So keep smiling. Okay. So guys, understood? Shivan, Chandra, Shreya, Risha, Shreya, everyone, I hope all good, happy. Okay, thank you so much for listening to me. Okay, so it's a great class. I have a great students over here. I'm so happy with it. So I hope you have understood. So let's move to the last question of the session. Okay, so can you read the question now? Y equal to x square and phase. Okay. About the LC oscillation, we'll do in the next class then. Okay, so you can see the Telegram link. So if you have any doubts, you can join that particular link and you can post your doubts there. Me and so many physics teachers will be there to help you guys. Okay, so we'll do the next question. So guys, please listen. Fine, Suraj, because everyone is fighting over here, right? So then how will I feel like taking the classes? Look, question. So in the figure, a long uniform potential wire AB is having a constant potential gradient along its length. Okay, potential gradient, it is the voltage per unit length, right? Okay. The null points for the two primary cells of EMF C1 and C2 connected in the manner shown are obtained at a distance of 120 and 300. So two different lengths are 120 and 300. Find the what? E1 by E2 and position of null point for the cell E1. How is the sensitivity of a potentiometer increased? Right? So you have so many questions. So we'll start doing it one by one. So you can find two kinds of connection over here, right? Yes or no? Okay, so you can see two kind of connection. One is this, when the EMF is connected and the cells are connected in the opposite fashion. So what will you have? Whether it is E1 plus E2 or E1 minus E2. Whether it is E1 minus E2 or E1 plus E2. Who will tell me? Fast. Whether it is potentiometer is whatever. Okay, someone was asking the principle of potentiometer. It is some potential will be dropped across this length of the wire, right? So whenever the potential at the secondary circuit, which I have marked as black, and the potential dropped across the wire are equal, the current passing through the galvanometer will be equal to 0. So when it is 0, you can write the potential over here and the potential over here will be the same, and the potential is directly proportional to length. As it is directly proportional to length, this potential I will be writing directly proportional to the length of 120. This will be directly proportional to its own length, 300. Understood? Yes, everyone was telling, I forgot to look at it. It is E1 minus E2. So E1 minus E2 is proportional to what? E1 minus E2 is proportional to how much? 120, and E1 plus E2 is proportional to how much? 300. So now what you can do? You can start dividing it. So E1 minus E2 by E1 plus E2 is equal to 120 divided by 300, right? You can cancel it off. Then 12, 4 go, 3 goes, it is 4 by 10, this is 2 by 5. So this you got it as E1 minus E2 divided by E1 plus E2, you got it as 2 by 5, right? Okay, thank you so much, Nancy. Then now you can just rearrange the things, okay, substitute it, simplify it, you will get the ratio which is E1 by E2 as how much? 7 by 3. Understood? So that is the answer for the first question. All good. So E1 by E2 ratio, you'll be getting it as 7 by 3. What you have to do is just simplify this. We are not wasting time on the simplification, that's all. Understood? So that is equal to 7 by 3. Yes? Okay, very good. Next, then E2 will be equal to how much? From here you will get E2 will be equal to 7 by 3 times E1. So they're asking what will be the length of E1 alone, right? So you know that E1 minus E2 was having how much of length? Okay, so E1 minus E2 was having, or was directly proportional to how much? 120, right? I hope you guys remember it was proportional to 120, right? Okay, so E1 minus E2 is how much? E2 is equal to 3 by 7. E1 is proportional to 120. Now rearranging, 7 minus 3 is 4 by 7. E1 is 120. So E1 is proportional to 120 into 7 divided by 4, right? So this is 210. So the length which is provided by the cell E1, which was the second question of ours, will be equal to 210 centimeter. Yes? Not 120, 210 centimeters. 210, not 120, 120, not 120, it is 210 centimeter. Yes? Okay, so we have the, very good, crystal clear. Shreya, Pratiksha, Rajni, all good, happy? Shivansh, Sukriti, okay, very good. Next, the last part of the question, sensitivity. What do you mean by the sensitivity? If the sensitivity is more, means it should be able to measure small value of the potential, right? Which means the potential dropped across unit length should be very small. Okay, what do you mean by the potential dropped across unit length? That is called as a potential gradient, right? Yes or no? So potential gradient has to be very small, which means potential gradient lambda is equal to V by L has to be small enough in order to increase what? In order to increase the sensitivity. So how will you make this very small? You have to make it small. How will you make it small? Either you can increase the denominator, which means the length of the conductor can be increased, or you can decrease the voltage. Understood? So these are the two things by which you can increase the sensitivity. Understood? Understood everyone? Yes? All good? Happy? Okay Ajit, your name is taken. Pratiksha, Ameer Sir, Kaniga, Daksh, Prajwal, Harish, Sukriti. So all happy? I hope you guys got a feeling that you have benefited something from my class, understood something, right? I hope that. So then it's a great thing, right? So rest of the questions what we are having over here will be discussed in our tomorrow's class. Don't worry at all, which not tomorrow, day after tomorrow. So be there at the right time, which is 1 o'clock. I don't want you to miss any of the classes. And what I want you guys to do is come along with your friends also, let them also join, let them also study. Okay, so let everyone know that there is a session for physics is happening for the board exam preparation, and tell everyone to be online at 1 o'clock for your Ameer Sir class, right? Shivan, Yo-Yo, Ameer Sir, Blitz, Dragon. Okay, so I hope you guys have understood this class. So if you feel like this class is more good, come and join the Vedantu class for the 12th crash course is happening. Come and join. You will be getting all the online classes, you will be getting the schedules, plans, previous year questions, then you will have the access to the recorded version, everything you will be getting, and you will get it for 3,799 instead of paying 12,000 if you can use this code. Okay, so AMECC, this is the code for me. Okay, this will be beneficial for me also, that's why. So if you use this code, you will get this course for 3,799. Go to this website or the link which you can see over here and apply AMECC and make it awesome. Okay guys, so I hope, just like I have said, I hope you guys have understood, you are happy. Then don't forget to like this particular video and share it with your friends. Ask them to come online in the next class onwards at 1 o'clock, and don't forget to subscribe. Okay, so bye guys, it's my time for you also, me also to leave because I'm totally hungry. Are you guys not hungry now? You're the best physics teacher ever. Thank you so much. That's more than anything, Sir Muttan. Right? Okay, thank you so much. My throat is not also good. I have to have my lunch. Okay, so let me go for some things. Non-veg, I don't know how many of you are non-veg. I don't know that, so I like it so much. So bye, see you guys, good afternoon, and make your day the best and awesome. Make yourself smile and make others also smile. Be the reason for others smile. Your life will be awesome. So bye, see you tomorrow. Thank you so much.